Today's lesson is on adding and subtracting polynomials. In order to add or subtract terms, you have to have the same base with the same exponent in order to add or subtract the terms. So, for example, x squared and x squared. That's the same base. They're both x's and they're both squared. So they're both x squareds, so I can add those terms. If you can't combine anything, leave it. Not everything will be a like term, and some things may not have any like terms. If you can't combine anything, don't try to. Just write your answer in standard form. Let's grab some paper and do a couple example problems. So I have x squared plus x squared. These are like terms because it's the same base, same exponent. They both are x squareds. So how many do I have? Well, remember, when terms don't have coefficients, when there's no number in the front, there's the invisible 1. So 1x squared plus another x squared is a total of 2x squareds. I have one, I have another, there's 2x squareds. I have 3y plus 9z plus 4y plus 3z. I'm looking for like terms. So this is a y. Are there any other y's? Yep, there's one over here, 3y and 4y. They're like terms because they both have a single y and the exponent is an invisible 1. So I have like terms, 3y's plus 4 more y's is a total of 7y's. And then I also see that I have z's, 9z's plus 3z's. Again, like terms, they're both z's. 9 plus 3 is a total of positive 12z's. And notice I'm writing my terms in alphabetical order here, y first and then the z. And I can't add those because those are not like terms, so I am done. Now I'm adding a lot more terms. Again, in order to add, they have to have the same base and the same exponent. That whole variable exponent thing has to be the same. So first I see that I have a 2x squared in the front. Do I have any other x squareds? I do here. That's a single x squared. Now, notice this term is 4x squared y. Even though it does have an x squared, these are not like terms. The variable part has to be exactly the same. They both do have an x squared, but this term has a y and this one does not. Since this does not have a y, they are not like terms. Only the x squared can be added. So 2x squareds plus invisible 1x squared is a total of 3x squareds. Now let's look at that 4x squared y. Are there any other x squared y's in this problem? Yes, this term, 4x squared y minus 10x squared y. Again, that variable part is the same. They both have an x squared and a y, or a y to the first. So I can combine those things together. 4 of that thing minus 10 of that thing, 4 minus 10 is a negative 6. So negative 6x squared y. Keep the variable part the same because that's how many I have. I have, 4 of them, minus 10 of them. I have negative 6 of that thing. I'm going to keep going. This is what I'm going to look at next. Xy squared. Do I have any other xy squareds? No. I do have an x, but again, doesn't match. It's not an xy squared. So I'm just going to copy that part down. Then I will write my x here. That's the only x term. Again, x is not the same as x squared because the exponent's not the same. And then the last thing I have to write down is this minus 7. It's the only constant, so I'll write that at the end. And that is my answer because I've added all of the things up that are like terms. Don't worry so much about the order on this kind of question. You do sort of want to go from most x's to least x's, which is what I did. The y's are a little bit tricky there. we won't be as critical on your order on these. What about subtracting polynomials? The most important difference is that when you subtract, the first thing you have to do is distribute the negative. You have to make sure that you're subtracting everything in the set of parentheses and not just the first term. Once you distribute, you're going to combine your like terms. Let's try those examples. So this problem has no parentheses. I'm only subtracting one other term, so I don't have to distribute anything. But I do want to ask myself, are these like terms? Can I combine them? So I have negative 10 a squared b squared minus a squared b squared. So if I look at the variable parts, a squared b squared, a squared b squared. They are in fact the same, so these are like terms. I have negative 10 a squared b squareds minus another a squared b squared. Again, that's an invisible exponent of 1. So negative 10 of these things minus one more of them is a total of negative 11 a squared b squareds. Now I'm introducing parentheses. The first thing I have to do is take this negative and distribute it to everything in the set of parentheses. Again, because I want to make sure that I don't just subtract whatever was in the front, I have to subtract everything in the parentheses, so each term has to get subtracted. So I'll rewrite it by keeping my first term the same. Negative times a positive is going to be a negative 7mn squared. Negative times a negative makes this positive m squared n. And now I combine any like terms. Careful here, because they both have an m and an n, but different exponents. So which two are like terms? That's the first one and the last one, because they both have an m squared and an n. This is m and n squared, so not the same. I can combine these two. 10 m squared n's plus one more m squared n is a total of 11 m squared n's. And then I just keep this part the same because it has no like term to combine it with, and that's my answer. Last one. Again, first step is to distribute the negative. I can keep the first part the same. This becomes a negative x, negative times a negative, plus 6x squared. I'm going to combine my like terms, starting with my highest degree of x squared. 7x squareds plus 6x squareds is a total of 13x squareds. And then I have a 12x minus x. Those are both x's. 12 x's minus a single x gives me 11 x's. And that's it.